Alright, so here's another example of AC factoring, and once again we know it's AC factoring because I have an 18 in the x spot, I don't have, or I'm sorry, in the x squared spot, I don't have a 1, and I can't get rid of that 18 using GCF. Right, so in this example, if you notice, the numbers are a lot bigger than any of the ones we've seen so far. Right, and the reason for that is that there's going to be times where you try to do AC factoring, but you realize, wait, 18, 33, and 12 actually have a GCF. Right, so again, this idea that anytime you factor, you should always try to remove any common factors before you begin any of the other methods. So that's showing up here again. So I can say this has a 3 in it, this has a 3 in it, and this has a 3 in it. So I'm going to remove that 3, and then that's going to make my life a lot easier because this is now 6x squared minus 11x plus 4. Right, and that these numbers are going to be much more reasonable to work with than if I hadn't have removed that 3. Right, so now I can come off to the side and say, all right, I got to try to keep factoring. This is a situation where AC factoring applies. So I'm going to forget about the 3 and just say, let's say, okay, AC, well, my A is 6 and my C is 4. 6 times 4 gives me 24. And my B value in the middle is the negative 11. And so I need to find a pair of numbers that multiplies to a positive 24 and adds up to a negative 11. And those numbers are negative 8 and negative 3. All right, so I'm going to, again, when I do GCF, I like to kind of forget about it for a second, organize my inside part. I'm going to turn this into 6x squared minus 8x minus 3x plus 4. Okay. And then I'm going to bring the 3 down and say, all right, this has a 3 in front of it. And so, again, we did this middle splitting of the negative 11 using these numbers so that I could use the grouping method. And so I'm going to just group these two and say this has a 2 and an x in common. And that leaves me with 3x minus 4. Right, and in my second group, remember, I'm looking for a match. Here's my second group, right? These two. And I'm going to say I need it to match this one, and it does except for the sign. Right, this is a negative 3, and this is a positive 3, and this is a negative 4, and that's positive 4. So the way that we fixed that was we said, let's just bring out a negative 1, and then that's going to match 3x minus 4. Okay, and then, again, outside of all of this, I'm going to use square brackets just so that, you know, all of our round brackets don't get all meshed up together. We can use square brackets as well. The 3 is sitting right outside of that. Okay, and so again, this inside, I'm just going to regroup 2x minus 1. All right, that's one of my factors. The repeating 3x minus 4, that's another one. Okay, and the 3 that we took out way at the beginning is still there. And so I'd say this last expression, 3 times 2x minus 1 times 3x minus 4, when I put all that together and multiply all that out, I'm going to get this expression at the top. Okay, so this uses a lot of skills all in one problem. We had to do GCF. We had to know how to AC factor and split up the middle term. We had to know how to use the grouping method to finish AC factoring, right, and then bring it all together at the end to get this expression. So this is a fairly complex problem, and it takes practice to get these, right? So we're going to practice one more. So in this example, I'm going to show you what happens when you forget. Like, let's say you look at this and you don't notice that 4 and 26 and 30 all have a 2 in them. What if we just jumped in and said, this is an AC factoring problem. I'm going to multiply together A and C and get 120 with a B value of 26. Okay, so again, I have off to the right, if you didn't watch the optional videos on AC factoring, I threw a little calculator tip in there, and I'm going to do it again here so that you can see it. If you want to use the graphing calculator, we have a very large number here, right? 120 has a lot of factors in it. We have to find ones that add up to 26. I can use the calculator. I'm going to follow these instructions, press y equals, divide the number that I want to find factors of, well, that's my 120, by x, and then I'm going to look in the table function, right? So I'm going to bring up my graphing calculator, and we're going to do that. Okay? So I'm going to clear out anything that's in there, right? I clicked my y equals, that brought me to this screen, and I'm going to type 120 divided by x, right? And that's the number I'm trying to find factors of. And I'm going to go to my table, so I hit second graph, and I'm going to bring up my list. I'm looking for a pair of numbers that adds or subtracts to 26, and scrolling down my list, it looks like, okay, well, 4 and 30, no, that doesn't work. Oh, look, I have 6 and 20. that's going to add up to 26. So I'm going to say that's the pair of numbers that I want. Right? So again, that's just a little calculator trick. If you're dealing with large numbers and they have a lot of factors, you want to save yourself a little bit of time. That'll help you out. Right? So I'm going to say 4x squared plus 4y squared plus 6y plus 20y plus 30. Okay? So remember, we forgot to take out the GCF at the beginning. We're going to take it out at the end. You're going to see that happen just like it did with the grouping method. So I'm going to pull out a common 2. Right? This first group here, right, has a 2 and a y. So 2y. Okay? And it looks like to get this expression back, I'm going to have to multiply it by 2y plus 3. Okay? And then my second group, this one, looks like it has a 10 in common. So I'm going to say plus 10. Okay? With a, again, 2y, squeeze that in there, plus 3. Okay? And now I'm going to regroup. Right? 2y plus 10. Okay? And a 2y plus 3. Okay? But again, we said the definition for factoring, if you're asked to factor, is that you're not done until none of the expressions can be broken down. And if you take a look at 2y plus 10, that 2 that we forgot to take out up here, right? We just jumped right into the AC factoring. It's showing up here. 2 and 10 have a 2 in common. So I can break that down and say this turns into 2y plus 5, right? And then the 2y plus 3 I didn't do anything with. That's just kind of, again, come along, right? So just like we saw with grouping, if you forget about a GCF and you don't take it out at the beginning, right, that we could have taken it out at the beginning, like we did in the example up here, but we didn't. We just jumped right into the factoring method. If you forget, look at your factors at the end and make sure there's no GCF in those, and you can remove it at the end as well, right? So two different ways to approach this GCF within a bigger AC factoring problem. Once we take it out at the beginning, and once we take it at the end, right? And it gives us the same answer either way you do it.